Scafechi once again, and we are going to talk about the rules of logarithms and their applications. Okay, all right. So, last time we wrote the rules down. Okay, so today we are going to just try. I'm going to attempt to prove them to you so that you understand why they are so. Okay. So let's start with the rule number 1. Now imagine, okay, we know that 2 exponent 10 exponent 2 is equal to 100. Okay, so this also implies that when you are asked to change it to the logarithmic form or make to the subject, it's just log to the base 10 of 100 is equal to 2. Okay, so this is our first equation. Now second equation, okay, if I write 10 exponent 3 is equal to 1000, it's the same as writing that log to the base 10 of 1000 is equal to 3. So this is the second equation. Alright, so furthermore, 100 times 1000, okay, will be equal to 10 exponent 2 multiplied by 10 exponent 3. You agree? Okay, so I can then say that 100 times 1000 is equal to 10 exponent 2 plus 3 based on the rules of exponential equations, where a exponent m times a exponent n is equal to a exponent m plus n. Yeah, that's where this is coming from. Okay, so now I can say that now this is also of the form, let's look at it carefully. It's also of the form b is equal to a exponent n. Remember I told you that this is the index, this is the base, and this is the number we are talking, the number we are actually focused on. So this is the index here, this is the base, and this is the number. So in other words, I can say that log of, into brackets, 100 times 1000 to the base 10 is equal to 2 plus 3. Remember that 2, this 2, we already said that 2 is equal to what? Log 10 to the log 100 to the base 10, and 3 is equal to log 1000 to the base 10. So therefore I can say that log of 100 times 1000 to the base 10 is equal to log of 100 to the base 10 plus log of 1000 to the base 10. Okay, nice. So let me make it let me use variables to represent all these. Okay, I'm going to use variables to actually deduce that indeed log to the base a of m times n is equal to log of m to the base a, plus log of n to the base a. Okay, so supposing 10 exponent a is equal to m, right? Then I can say that log of m to the base 10 is equal to a. Similarly, if 10 exponent b is equal to n, then I can say that log of n to the base 10 is equal to b. Right? Good. Now let me multiply m by n. So if I multiply that, then at the other side of the equation, m is equal to 10 exponent a, and then n is equal to 10 exponent b. So I can say that m times n will be equal to 10 exponent a plus b. 10 exponent a plus b. Okay, and this is also of the form b is equal to a exponent n. So therefore I can say that log, this is the index, this is the base. So I can say that log of m times n to the base 10 is just equal to a plus b. But then what is a? What is b? A is log m to the base 10 and b is log n to the base 10. So I can just substitute and say that therefore log to the base 10 of m times n is equal to log m to the base 10 plus log n to the base 10. So I've just proved the first rule. Okay, just remember that it's so important to know how to prove all this. Okay, so I'm just trying to let you understand. Okay, so with the rest I'll just rush through. Okay, I'll just rush through. So to prove that the second law, which is that log m over n is equal to base a is equal to log ma minus log an. So we already know that we assume that 10 exponent a, we are just using the same assumption. Okay, so m divided by n will be equal to 10 exponent a divided by 10 exponent b, and according to the rules of exponential equations, this was the same as 10 exponent a minus b. So therefore m over n is equal to 10 exponent a minus b. Now this is our number, this is our index, this is our base. So therefore I can say that log to the base 10 of m log to the base 10 of m over n is actually equal to a minus b. But what is a? What is b? We already said here that a is log m to the base 10 and b is log n to the base 10. So therefore I can say that log m over n to the base 10 is equal to log m to the base 10 minus log n to the base 10. Okay, so we've proved that. So just the thing what you must note is that they all have to be in the same base. So if this a, this a, this a, so let them be a. I mean, this you can put any variable here. So far as they are the same, this rule is correct. Okay, so let's prove the third rule, and then I think that'll be it. So the third rule states that log of n exponent b to the base a is equal to b times log of n to the base a. Okay, so now let's assume that n is equal to 10 exponent a. If that is so, then it implies that log of n to the base 10 is equal to a. Now, what is n exponent b? N exponent b is, you know that n is 10 exponent a, so it's just 10 exponent a exponent b. So with the rules of exponential equations, you multiply the two. So n exponent b would therefore be equal to 10 exponent ab. Right, okay. So now we have this. Now this is our index, this is our base, this is our number. So log of n exponent b to the base 10 will be equal to ab. Right? Now what is a, what is b? Okay, this ab is the same as ba, right? But we stated that a is equal to log n to the base 10. So therefore log n exponent b to the base 10 will be equal to b times log of n to the base 10. So therefore log of n exponent b to the base 10 is equal to b log n to the base a. Yeah, so we proved it. Okay, so we need to apply these logarithms. Okay, so for example, you are being given a question that if log So this question time. If log 3 to the base 10 is equal to 0.4771 and log of 5 to the base 10 is equal to 0.6990, then find a log of 15 to the base 10, b log of 5/3 to the base 10, and C is log of, say, 25 to the base 10. Okay, so how do we do that? Now let's take A. I'll solve the first and then the last. Okay, then you try your hands on this. So log of 10, 15 is the same as log of, we know that multiplying 5 by 3 gives 15, right? Or 3 by 5. So that's it. And this, we can go back to the rule which says that when two logs, which says that, let me state it, is log of m times n to the base a is equal to log of m to the base a plus log of n to the base a. So these are n, these are m, these are a. Okay, so we can say that, we can confidently say that log of 10, log of 3 times 5 to the base 10, is equal to log of 10, log of 3 to the base 10 plus log of 5 to the base 10. But what is log of 3? What's log of 5 to the base 10? It was given to us in the question that log of 3 to the base 10 is 0.4771. So this is equal to 0.4771 plus 0.6990. Okay, and this will give us 1.1761. So that's your final answer. And with the second one, let me make it 75. Okay, so that will be a little difficult. Okay, so C, log of 75 to the base 10. 75 is just 25 times, I can say it's 25 times 3. You can find other ways, but we will just arrive at the same level. The least common factors. Okay, the least common factors are 3, 5. Okay, so we can say that it's equal to log of 10 to brackets 25 times 3. Okay, 25 times 3. But we're giving, the reason why we are breaking them down is that we are giving only these numbers 5 and 3. So you have to express the numbers in the form of these factors. Okay, that's why we are expressing them that way. Okay, so we have this, but 5 squared is 25. Okay, 5 times 5 is 25. So I can say that log of 75 to the base 10 is equal to log of 10 into bracket 3 times 5 squared. Okay, so now I have log of so I have log of 3 times 5 squared to the base 10. So this is the same as log of 3 to the base 10 plus log of 5 squared to the base 10. Remember that we gave, the third rule says that if I have a number, say log of a exponent, log of n exponent b to the base a, it's the same as, I'll just have to bring this exponent to this side of the, to this side. Okay, it's like, I'll just have to bring the b to this side. Okay, so the same as b times log of n to the base a. So similarly, I can say that this equation is the same as log of 3 to the base 10 plus 2 log 5 to the base 10. Okay, but what is log 3 to the base 10? Log 3 to the base 10 given in the question is that's given in the question is 0.4771, and this is 0.6990. okay, so this will be equal to 0.4771 plus 2 into brackets. The 2 here is multiplying this, so times 0.6990. So you evaluate, and then yeah, that's the answer. So it's okay. Let me do it. So it's 4771 plus 1.3398. Yeah. So evaluate. Actually, let me 0.4771. That's 1.3398. I don't have a calculator. That's why I'm doing that. So 6. So 11, 8. So we have 1.8169. Yeah, so that's what we have. Okay, thank you very much.